Hi everyone, welcome to the online classes of Dream Fusions. Today in this lecture of strength of materials, we will discuss about the different types of loads that a structure has to bear. So the loads can be of different types. So first of all, we will discuss what a load is. So a load is the combined effect of all the external forces that are acting on a body. So suppose this is a body and it is experiencing two forces, F1 and F2. So the load over this body will be the sum of the forces, all the forces that are acting on this body. So in nutshell, loads can be defined as the combined effect of all the forces that acts on a particular body. So now we have understood what the load is. We will discuss about the different types of loads. So the first type of load that we are going to discuss is concentrated load. So in concentrated load, the most important thing is that this type of load acts on a small area. So here in this diagram, you can see that this is a beam. This is a beam that is simply supported on two columns. It is supported on two columns at the end. So these are the columns. And suppose on this beam, there is a brickwork which is resting on the, not on the end, but on the anywhere between the ends of the beam. These two brickworks are resting on the beam. So the load coming from these brickworks would be W1 and W2. So this type of load, which is acting on this on a relatively smaller area. Here you see this load is acting on this surface area of the beam only. So it is acting on a very small area. So these type of load are known as concentrated load. So the most important thing that we have to remember in concentrated load, that these kinds of load acts on a very small surface area of the element. So now we have discussed about concentrated load. We will discuss about the next type of load, that is uniformly distributed load. So in uniformly distributed load, contrary to the concentrated load, this type of load acts on a large area. It is named as uniformly distributed load because the load is distributed uniformly over the entire span of the element. So here in this diagram, what we see that suppose this is a beam. This is a beam, and this beam is simply supported on two columns. These are the columns on which the beam is supported, and a steel plate is resting on the entire surface of the beam. So this is the steel plate which is resting on the entire surface of the beam, and the weight of the steel plate is W. So the entire surface area of the beam will experience the force, that is the weight of the steel plate. So this type of load can be called as uniformly distributed load. So here it is shown as this. So on this beam, you see that a uniformly distributed load is acting on the entire surface of the beam. This beam is simply supported. So one important thing is there, that this is the load W. This is load W, which is spread over the entire surface area, and the unit of it is kilonewton or Newton per meter. So per meter length, the weight is W kilonewtons. So if you have to calculate the total weight of this steel plate, what you have to do, the total weight would be capital W, which will be equal to weight per unit length into the total length of the beam, that is L in this case. So total weight will be in, so small w is in kilonewton per meter, length is in meter. So total weight will be in kilonewton or Newton. So you should not confuse between small w and capital W. Small w is the weight per unit length, whereas the capital W is the total weight of the steel plate. Here, one important thing is there, that for the convenience, the uniformly distributed load is converted to an equivalent concentrated load, which acts at the center of gravity of the loading. So what happens, for the calculation purposes, what we do, we assume that a total weight of the uniformly distributed load, that is W, is acting at the center of gravity of the load. So it will be assumed at W acting at the center of gravity of the load. This is only for the calculation purposes. So now we have discussed about uniformly distributed load. The next type of load that we are going to discuss is uniformly varying load. So in uniformly varying load, the load will uniformly vary from zero intensity at one end to the designated intensity at the other end. Designated intensity could be the maximum intensity. So I will give you an example of this. Here you can see that this is a beam. This is a beam which is resting on two columns. These are the columns. So there is a brickwork which is triangular in shape, which is resting on the beam itself. So here you see the load on the beam would be 0. And the load, since the triangular shape of the brickwork, the load will progressively increase, and at this end, the load will be maximum. At this end, the load will be maximum. So this type of load is called uniformly varying load, since the load is varying uniformly from one end to another end. So here, in this case also, for the calculation purposes, what we do, we consider this uniformly varying load as an equivalent concentrated load acting at the center of gravity of the loading. So here in this case, suppose if this load is W kilonewton per meter, then we will consider that this load is acting at the center of gravity of the loading. So here the center of gravity lies at a distance L by 3 from one end and 2L by 3 from the another end. So this type of load is known as uniformly varying load. Now we will discuss another type of load, that is concentrated movement. So in concentrated movement, what happens? Suppose this is a beam and this beam is simply supported on two columns, and there is a bracket. This is a bracket resting on a column on the beam. This is a bracket resting on the beam, and the force of W kilonewton is applied on the bracket, and this force is at a height h from the top surface of the beam. So uh, I will repeat, there is a beam which is resting on the columns. It is simply supported in two columns, and there is a bracket, and we are applying load W, which is at a distance h from the top surface of the beam. So that in that case, a moment will generate. So a clockwise movement will generate, and the value of this moment would be, in the previous lecture, we have discussed that moment is force into distance. So here the value of force is the weight itself, and the distance is small h. So the moment will be WH. So WH kilonewton meter will be the value of the moment that is generated. So in concentrated movement, a beam is to accommodate a load on a bracket which is mounted on it, which get transmitted on the beam, is a concentrated movement. So these were all the different 4 types of loads that any structure has to undergo. So I hope that you all have understood the concept of different types of loadings very clearly. And that's all for today. Thank you so much.